Hello, this is Learning Plan 2. In this learning plan, I'm going to show you how to use common test instruments for use in electrical trades. The objectives in this learning plan are: explain how to troubleshoot fuses using a continuity tester. Explain how to properly use a voltage tester to test for voltage in a circuit. Explain how measurements are displayed on a digital multimeter. Describe what each CAT rating means in a test instrument. Describe the procedure required to set a multimeter to take resistance measurements, DC voltage measurements, AC voltage measurements. Also, understand how to properly and safely test fuses in an energized disconnect switch. Understand how to properly and safely test to ensure that a disconnect switch is grounded. Describe the procedure required to set a multimeter to take an inline current measurement. And describe the procedure required to use a clamp-on ammeter to take a current measurement. To start out, we talk about continuity testers. Continuity is set by turning a dial on your digital multimeter to what looks like a sound coil. Okay. So when using the continuity tester, you can check fuses to see if they're good or bad. So fuses can be checked using a continuity tester set to measure continuity, placed across a fuse that has been removed from a circuit. Key term here is removed from a circuit. Okay, if the fuse is good, the continuity tester will ring at you. It will give you a beeping noise. If it is bad, it will do nothing and will display over limit or overload. Digital multimeters use an LCD to show electrical measurements and have multiple functions on them. So you can see there's multiple functions on this meter: off, AC voltage, AC millivolts, DC volts, DC millivolts, ohms, capacitor check, temperature, AC amperage, milliamps, microamps, DC amps, milliamps, microamps. So this meter that we have here has a lot of different options. Not all meters are going to have these options. Some abbreviations. You can look at these boxes down here, but the big ones I'm going to talk about are in the top. So M on a multimeter stands for meg. So that's a unit of measure. And this symbol here stands for ohms. Now if we go down to this box here, it's AC millivolts, DC volts, DC microamps, DC millivolts, DC volts, and DC milliamps. Okay, the biggest thing to remember here is don't just look at the numbers. Okay, because you could have 12 milliamps, but your display could also display 12 amps. Okay, there's a big difference between 12 milliamps and 12 amps. So you can't just look at the numbers, you must look at the units to the right. The applications in which a digital multimeter may be used are classified by the IEC 1010 standard into 4 overvoltage installation categories. Okay, so we have multiple different categories of meters. We have category 1, 2, 3, and 4. Basically, you need to be aware that there are different classifications of meters, and certain meters are not capable of measuring higher voltages. A standard multimeter can be used with attachments or adapters that allow the multimeter to measure almost any type of variable. Okay, so you can actually attach a temperature probe to a multimeter to measure temperature. You can measure a device to measure light, airspeed, humidity. Okay, these are separate attachments that can be attached to a multimeter. A digital multimeter can be used to measure the resistance of a circuit or component removed from a circuit. Okay, so troubleshooting a contactor coil is a good application for measuring resistance in a circuit. So here we have what appears to be a NEMA style motor starter. This motor starter, what we're doing with the multimeter here is measuring the coil resistance. Okay, so maybe this motor starter is not functioning properly. Maybe it's not starting when somebody pushes the start button. So a good test to do is to test the coil. The coil should read some resistance. Okay, it shows on the meter 150 ohms. If it reads 0, that means the coil has a short on it. If it reads OL or over limit, that means the coil is open. An ohmmeter can be used to check for open circuits on a PC board. Okay, so you can actually check a circuit on a PC board with an ohmmeter to see if there's a break. Fuses can be checked using a multimeter set to measure voltage. So if you have a multimeter set to voltage, you can test across your power coming into a disconnect. Okay, so you test line 1 to 2, 2 to 3, 3 to 1, testing for voltage. And then you repeat the same thing on the bottom. Or you can check voltage across them. Be careful with this, because if you're testing a fuse with a voltmeter function, you're going to be, if the fuse is open, you will read source voltage. So say you have 240 volts AC. If the fuse is blown or open, your meter will read 240 volts AC. If the fuse is good and not open, it will read nothing. So if you've ever used a digital multimeter, you'll notice if you're in a building with a lot of fluorescent lights, there will be some sort of reading on the display when you're not measuring anything. And some people may say, well, there's something wrong with my meter because it's reading something, I'm not even using it. What that is a fluorescent light sends out, there's ghost voltages they call it. So your test leads act as an antenna and pull in those voltages. So if your meter reads something and you're in a highly fluorescent environment, I wouldn't be too concerned with it. A digital multimeter used to take inline current measurements becomes part of the circuit being tested. In your lab activity today, you will see how this is done, but if you're using the current meter or ammeter in a circuit, you must make it part of the circuit or put it in line with the circuit. A clamp-on ammeter eliminates that problem with having to break the circuit. A clamp-on ammeter measures the strength of a magnetic field around a single conductor. So basically you clamp the clamp-on ammeter around a conductor, you want to know how much current is flowing through it, and it measures the current in that conductor. Now the reason or how it works is current run through an inductor generates a magnetic field. And this ammeter picks up on the intensity of that magnetic field. An oscilloscope is a device that gives you a graph reading of voltage measurements. So an oscilloscope is a test instrument that displays an instantaneous voltage image on a graph. So this is a device that's used commonly on AC circuits and DC circuits to kind of see real-time instantaneous readings of what your circuit is doing. A meg-ohmmeter is a device that detects insulation deterioration by measuring high resistance values under high test voltage conditions. So a meg-ohmmeter, or megger for short, is a device used to test insulation on motor windings, transformer windings, things like that. That insulation is supposed to protect, say, the outer frame of a motor or the other windings in a motor from electrical induction, I guess you could say. So this tests the insulation integrity and makes you sure that your windings and your insulation are good. An infrared temperature meter can be used to assess the condition of electrical connections and operating equipment. So condition of fuses in a disconnect or connections can be tested with an infrared temperature meter. So if you have a loose connection on a contactor or a disconnect or any electrical component, what you have is a thing called arcing. And arcing produces heat, much like welding. So that heat will be able to be read by this infrared temperature meter, and you can indicate points of failure. A phase sequence indicator is a device used to determine phase sequence and open phases. So this is commonly used to indicate motor rotation. This is probably the most common application of this. So if you have a motor that is installed in a machine and you need to test to see which wires go to which lead on the motor, you would use a phase sequence indicator to make sure that you install the wires correctly and your motor doesn't rotate backwards when installed. So that's it for test instruments. Good luck on your lab. See you next time.